Hello class, welcome to today's lesson. Our next topic for today is the second type of binary compound, which is covalent compounds. Now before we start with the lesson, don't forget to subscribe to Don Flavor channel. Click on it to subscribe. What are covalent compounds? Covalent compounds are those whose molecules contain bonds formed through the sharing of electrons between two or more different atoms. Covalent compounds contain covalent bonds. What are covalent bonds? Now, covalent bonds are formed by the sharing of electrons between atoms. Covalent bonding involves different atoms of the same element. Now, when we say it involves different atoms of the same element, you can say H2, which contains same element but different atoms. So, hydrogen and hydrogen. Or different elements sharing electrons in their outermost shell to attain a stable electronic configuration. So example of this is, we can talk of H2O. This is a different element. This is also a different element. So this hydrogen and this oxygen, they form what we call the covalent compounds. Examples of covalent compounds, we can talk of carbon dioxide. So examples. We have one, carbon dioxide. We have two, carbon monoxide. We have methane. We have ammonia. Oxygen gas, etc. In covalent bonding, the number of electrons and atoms needs to be stable is what it stands for sharing. Now, let me explain this. Now, this means, let's take hydrogen molecule, so H2 hydrogen molecule. Now, hydrogen is having atomic number 1. Now, for electronic configuration of hydrogen, we say it's what? 1. And how many more does hydrogen needs to be stable? That is 1. So this 1, which the hydrogen needs for it to be stable, it will share for it to be stable. So formation of covalent bonds. Now, the first example. Example 1. Hydrogen molecule. That is H2 gas, hydrogen gas. Now, let me write hydrogen gas here. Now, you can see that there are 2 atoms of hydrogen present here. So let's write first hydrogen and the second hydrogen. So there is 1 hydrogen here, there is another hydrogen here, making up to 2 hydrogens present here. Now, hydrogen on the periodic table is having atomic number 1. Hydrogen here is also having atomic number 1. Now, the electronic configuration for hydrogen is 1, same as this. Now, this means hydrogen needs 1 more to be stable. Hydrogen here also needs one more to be stable. We are going to draw for the normal hydrogen here and the normal hydrogen here. Don't forget, for the formation of covalent bonds, each hydrogen is going to share, or each element involved is going to share their what? Their electrons. That is their outermost electrons. Now, the hydrogen here is going to share one, and the next hydrogen here is also going to share one. So I have one hydrogen here. I also have one hydrogen here. So the number of electrons which needs to be stable, so it needs one to be stable. Then the one it needs for it to be stable, that is the one it is going to be shared. So I have hydrogen 1, hydrogen 1 like this. And the next one is they are going to share their electrons so that it will be what? Stable. So there is one here, there's another one here. So first of all, we are drawing for this. This is going to share the one. This is going to share the one. This is also going to share the one like this. So hydrogen here, the hydrogen here will be how many? 2. And the hydrogen here is also going to be 2. So hydrogen shared 1, and the hydrogen here also shared 1. So they join together. So this one is for this and this one is for this. Then you're going to get first hydrogen is 2 and the next hydrogen is also how many? 2. Let's take the next example, which is example 2. Example 2. Let's take oxygen gas, O2. So O2. 2 atoms of oxygen present. So there is oxygen here, there is another oxygen here. Oxygen on the periodic table is having atomic number 8, same as this one. Electronic configuration for oxygen is how many? It's 2, 6. Electronic configuration for oxygen 2, 6 here. Now, oxygen needs 2 to be stable. Oxygen here also needs 2 to be stable. This is going to share 2. This is also going to share how many? 2. So let's draw for the normal oxygen here. 1, 2, then 6. 1, 2, 1, 2. How many is oxygen going to share? Oxygen is going to share 2. So this is what oxygen is going to share to this. So let me draw it here. Now let me draw the next oxygen. That is 1, 2. Then 1, 2, 1, 2. So 1, 2, 3, 4. How many more? 2 more. So it is going to share the 2. 1, 2. Now don't forget, we said the number of electrons which is going to be shared is what it needs to be what? To be stable. So 1, 2. This is the 2. 1, 2, 3, 4, 5, 6. 2, 1, 2, 3, 4, 5, 6. So these 2 and these 2, they are going to join together. So let me draw the first 2. This is 1, 2. Let me also draw this 1, 2. So this one is for this and this one is for this. First of all, let me write this, which is 2 and 6 here. 2 and 6. You can choose not to write it. Then here Now they are going to join like this. Okay. Now let me draw this 1, 2, and this 1, 2. So 1, 2, 1, 2, 1, 2, 1, 2, then 1, 2, 1, 2. Left with these two. Let me bring it here. 1, 2. So this is for this. Then 1, 2 for this. 1, 2 for down. 1, 2 for down. Then this 1, 2. I'll bring it here. 1, 2. I hope you are getting it. So 1, 2, 1, 2. 1, 2, 1, 2. This 2 is for this. Then 1, 2, 1, 2, 1, 2, 1, 2. Then this 2 comes here. Now I'm going to get 2 here. Then 1, 2, 3, 4, 5, 6, 7, 8. 8. Same as this 2, 1, 2. Then this 1, 2, 3, 4, 5, 6, 7, 8. Then 8. So the whole of this one is taking the whole of this circle, and the whole of this one too is taking the whole of this. So 1, 2, 3, 4, 5, 6, 7, 8. Let's take the next example. Example 3. Let's try ammonia. Ammonia, which is NH3. NH3. Now, there is nitrogen, there is hydrogen, there is hydrogen, there is another hydrogen, nitrogen, 3 of the hydrogens. So nitrogen and 3 of the hydrogens here. Nitrogen on the periodic table is having atomic number what? 7. So 7, hydrogen 1, hydrogen 1, hydrogen 1. Now let's write the electronic configuration for this. I have 2 and 5. I have 1, I have 1, then 1. Now nitrogen needs 3 more to be what? To be stable. Nitrogen needs 3 more to be stable. So it means nitrogen is going to share 3 electrons for it to be stable. Hydrogen here also needs 1, but it is going to what? Share the 1. This is going to share 1. This is going to share 1. This is also going to share 1. So let's draw for nitrogen. Now, since there are 3 hydrogens here, we can just draw the first let's draw for the first nitrogen. So nitrogen, let's draw. So we are going to draw. So let me bring it here. 1, 2 for nitrogen. 1, 2. We are drawing for this. 1, 2, then 5. So let me draw 1, 2 here. Then 5. There is 1, 2, 1, 2, 3, 4, and 5. Are you getting it? So this is the 2. This is also 2 and 5. Why? Because it needs how many more to be stable? It needs 3 more to be stable. And it is going to, the number of electrons it needs to be stable is what it is shared. The 3 its elements needs to be stable is what is going to be shared. So this 3, it needs 3 to be stable, and this 3, it is going to share the 3. Now I have hydrogen here. There is 1 hydrogen here. So let me draw hydrogen here. Let me also draw hydrogen here. Then the next hydrogen, let me draw it here. Are you getting it? So nitrogen needs 3 to be stable. And the 3 it needs to be stable, that same 3 is what nitrogen is going to share. So nitrogen needs 3 to be stable. And this 3 it needs to be stable is what nitrogen is going to be shared. So we draw for 2 here, and the 5. 1, 2. How many more is needed to obtain 5? It needs 3 to obtain the 5. And this 3 it needs, that is the same 3 it is going to share. So hydrogen here is 1. Hydrogen here is also 1. Hydrogen here is 1. Then N here is 2, 5. So this is the normal what? NH3. Now the next one is each is going to share their electrons. Now hydrogen needs 1 to be stable. And the one it needs to be stable, that is the same one it is going to share. Nitrogen needs 3 to be stable. And that 3 it needs to be stable, that is the same 3 it is going to what? Share. So we are drawing for the next one here, which is this. Then let me draw this one. 1, 2. Now let's come to this one. This and this is how many? 2. So there is 1, 2 here. This 2. This and this is how many? 2. So there is 1, 2 here. For this and this is how many? 2. So it's here 1, 2 like this. Are you getting it? So we are going to get, for this hydrogen, we are going to get H2. For this one, for this hydrogen, we are going to get H2. For this hydrogen, we are going to get H2 for here. And for this nitrogen, we are going to get, and this one is how many? 2. Then we count 1, 2, 3, 4, 5, 6, 7, 8. So 2, 8 like this. So this is all about covalent bonding. Now let's take the last example. Example 4. Example 4. Example 4. Example 4, we are taking carbon dioxide, CO2. CO2. So there is carbon, there is oxygen, there is oxygen. Are you getting it? Carbon on the periodic table is having atomic number 6. Oxygen is what? 8. Oxygen here is also 8. Carbon 2, 4. Oxygen 2, 6. Oxygen 2, 6. Are you getting it? So let's draw for the normal carbon. Carbon needs 4 more to be stable. So this means carbon is going to do what? To share 4. So there is carbon, there is oxygen, there is oxygen. This oxygen needs how many? 2. This oxygen needs how many? 2. It needs 2 to be stable. This also needs 2 to be stable. So it is going to share the 2. This needs 4 to be stable. It is going to share the 4. So carbon, let's draw for carbon. 2 and what? And 4. So there is 1, 2, 3, and 4. So this is carbon 2, 4. Oxygen here 2, 6. 1, 2. There's how many? 1, 2, 3, 4, 5, 6. There's another 1, 2 here. 1, 2, 3, 4. So sorry, 1, 2. 1, 2, 3, 4, 5, 6. So you can bring these two here and here, or here and here. You can also, if you like, you can bring these two here like this. You can bring it here like this. 1, 2, like this. Are you getting it? So this is 1, 2. So this is 2 and 6. 1, 2, 2. 1, 2, 3, 4, 5, 6. 6. This is 2 and 1, 2, 3, 4. This is 1, 2. So it means it is sharing the 4. It will give 2 to this. It also give 2 to this. So this is also 2 and 6 like this. So let me draw the next one. Let me draw the next one down. So I have 1, 2, and this. So look at this. Let me also draw this one. This one. So there is 1 and 2 here like this. Let me also draw for this 1 and 2 like this. So these two, these two, these two, and these two. Now, next one is, let me join this like this. So there is 2 here, 1, 2. There is 2 here, 1, 2. There is how many here? There is 4 here. So 1, 2, 3, 4, like this. Here today is the 2. Let me draw this. Let me join this. There is 2 here, 1, 2. There is 2 here, 1, 2. There is 4 here, like this. We are going to join this and this. So 1, 2, 3, and 4, like this. Now let me write. This one will be 2 and 1, 2, 3, 4, 5, 6, 7, 8. 2, 8. This is 2. 1, 2, and 1, 2, 3, 4, 5, 6, 7, 8. 2, 8. This is also going to be 2, 1, 2, then 1, 2, 3, 4, 5, 6, 7, 8. 2, 8, like this. So this is what we are going to get. So for, because this carbon needs 4 more to be stable. Are you getting? If it needs 4 more to be stable, it means we are going to get 2H, which is here. So it needs 4 more to be stable. So therefore, it needs to be stable. That's the same 4 it is going to share. That's why we are getting 2, 8. It needs 4 more to be stable. That is why we did it. We had 2, 8. This one too needs 2 more. It needs 2 more to be stable. So if you need 2 more to be stable, then you are going to get what? 2, 8. That's why when we did, we had 2, 8. Then same here, same oxygen, we had 2, 8 like this. So just look at this. This is how we are going to do it. So this is for the formation of covalent bonds. Now let me give you an assignment. Let me give you an assignment. Or try, let me say a try work. So try. So you are going to draw for the formation of we have 18 C8 you draw for Cl2 chlorine gas. Then you write the physical properties of covalent compounds. Okay, so thank you all for enjoying my class. I will leave my number. Then when you solve this, you send it to me so that I check it for you. Please don't forget to subscribe to my YouTube channel. Please tap on the subscribe button to subscribe to my channel so that whenever I make a new video, you're going to see a notification. Thank you.